Alarm bells are ringing that artillery is running out. Despite the drone revolution, it's the world's most in-demand weapon that could yet decide the fate of Ukraine. We've come to the BAE Systems factory in Washington, the largest ammunition factory in the UK, to look at how they manufacture 155mm artillery shells. We've been looking at the weapons that are changing the nature of war, but artillery is one of its constants. It's one of the weapons that is still defining conflicts. I've seen that in Ukraine. I've been with the crews of AS-90 guns. I've been with the crews of Soviet-era guns on Ukrainian army blasting Russian positions. Why is it important? Well, because artillery can't be jammed. It's immune to electronic warfare. The staff here are now working shifts 24/7, round the clock, 7 days a week. Let's go and have a look and see how they do it. An artillery shell is, in essence, just a large bullet that's fired down a large barrel by a large explosion. But modern artillery shells tend to have one key difference, and that is that unlike bullets, which are solid lumps of lead, artillery shells are packed full of explosives, and that means when they hit their target, they deliver two kinds of effect. There's the kinetic effect, the lump of metal hitting a target at speed, just as with a bullet, but there's also the explosive effect. The cargo inside the bottle explodes on the target. There are essentially three key parts to an artillery shell. At the front, there is the fuse that determines when the explosives inside the shell ignite and explode. There's the bottle, or the body of the shell itself. That is the largest part that gives us its shape. That is normally hollow and filled with high explosives. And then at the tail end is where the propellant charge goes. Now, that is what propels the shell out of the barrel towards its target. And the first stage of making any artillery shell begins in the forge.
These are the billets. This is the actual start of the process.
Billets,
yeah,
that's what you call
billets,
them.
Yeah.
And so they're basically lumps of
steel.
Lumps of steel.
Yeah.
How heavy is each
About
one?
65 kilograms, I think these ones are.
Okay, so that's about twice as heavy as the finished product.
Yeah. This is where the billets get loaded on, and then the robot picks the billet up, puts it into an induction heater. You can follow this. Heats them up to about 1100 degrees.
And that's in along here, 1100 degrees.
Yeah.
Wow, okay. But I'm not feeling much heat.
No, you won't. And it takes it's actually about 45 minutes to get right through.
Quite satisfying to see.
It is, don't I? From there, they come out up through the floor onto a cooling conveyor, which runs them up to what we call the belt, and they're cooled about 3 hours.
How is an artillery shell fired? So once it's been loaded into the barrel, the breech has been closed. A firing pin strikes the propellant charge. That creates an explosion. The explosion creates hot, expanding gas at the bottom of the barrel behind the artillery round. That heat then seals the obdurator. The obdurator is a part of the shell which stops those gases escaping, and therefore the only way for those expanding gases to get out of the barrel, to have the space they need, is to propel the shell forwards along the barrel. At the same time, there is normally a part on the shell called the driving band. This is a soft metal, sometimes copper, around the thickest part of the shell, which engages the rifling in the artillery barrel. So as that shell is propelled down the barrel, it starts to spin, and that gives it more accuracy. The next thing we would see is a puff of smoke and possibly flame as those expanding, burning gases erupt out of the barrel, sending that shell hurtling towards its target. This is the swager, right?
This is the swager, yes.
So you've taken those forgings, turned them slightly so they look silver, and what happens in here?
What happens in here is they get heated up from an induction heater, very hot, pushes it into a mould and shakes it into shape.
That's the hollow end of the cylinder.
Yes, the hollow end, and then that then forms the shape what you would see as like you'd think is a shell.
Behind me is a furnace. This is where they're heat treating the shells. So they go through a process of washing them, heating them, cooling them, washing them. And that's all about affecting the tensile properties of the steel. That affects how it fragments, how it explodes when it's used as a weapon. But essentially what we saw is the oven doors opening, a crate full of shells being pushed into the flames, and they're going to sit there now for about an hour and 40 minutes.
This is the last stage of semi-finish. It'll come to me and I'll hardness test every shell. So I'll get 24 shells which have already been linished for us. And what I've got to do is lift the shell onto here, place it onto there so it's in the correct position. This one's going to make the indentation that I showed you before on the shell. As you can see there, you see the indentation now.
It's pretty tiny.
Yeah. So now this camera lens is going to measure that for us.
Yep.
That will bring us bang on to the outside of the circumference there. So that is the weight of that shell now, 34414, so that's fine.
And do you write that on now?
Yes, I'd write it on there, and that is above the softer shell I've got already, so that's fine to go over into that basket.
Fantastic. In July 2022, I spent time with a Ukrainian Howitzer crew who were operating a Muster B, that's a 122mm gun. What I remember was the speed of how quickly they deployed. They got the fire order, they scrambled onto the road, drove to a firing position they'd already recce'd, set up the gun, fired, collapsed it, and disappeared. Because the risk for them was that as soon as they fired that first shot, they could be located by counter-battery radar. There was a slim chance even then of being spotted by surveillance drones, so they didn't want to spend a long time exposed in the open where they were firing. A few years later, I spent time with an AS-90 crew. So that was a Ukrainian crew operating an AS-90 mobile howitzer, a 155mm gun that had been donated by the UK to Ukraine. Very different threat, different environment, really showed me how the war had changed. That gun was in a concealed location near the front line. It rumbled out into a firing position, fired a couple of shots, and then disappeared. The risk for them was very much drones.
Number one, fire!
Personal experience with artillery as a journalist goes back even further. I saw British airborne gunners from the 7th Royal Horse Artillery firing 105mm guns in Kajaki in Helmand in 2008. And then I saw that same type of gun being used by Ukrainian forces defending Bakhmut. I've also been on the wrong side of artillery barrages, and that's perhaps the most powerful way I've ever had of experiencing or understanding how powerful artillery can be as a weapon. And the first time it happened, I'll never forget it, was the second day of the war in Ukraine, and I was on the northern edge of Kharkiv city on a snowy embankment on the inside of the ring road, which was effectively the front line. Suddenly I saw all of the soldiers running into their narrow shell scrapes. We heard the sort of whistle of shells hurtling over our heads, and then the thunderous boom as they exploded behind us because they'd been fired beyond the position where we were. Back in Kharkiv, and this time in the city, and with some medics who were treating wounded civilians when we came under a second rocket bombardment, a double tap strike, and that was similarly terrifying. This is stage 3 of the process. It's the finishing. Shells which start off like this semi-finished shells. They pour out the insides of them to make sure that the inside is smooth and that the walls of the shell are the right diameter. The staff here check the thickness of the walls. They use special calipers. You can see over here those green calipers to check. They're very precise. Everything's basically got to be the right shape. And this is the finishing section, same as we've just seen at the Royal Artillery line, but it's much more automated.
Fully automated line. This is the final stage on the shop floor.
So you're taking in sort of semi-finished shells, putting out finished shells.
Yeah.
How long does it take from the journey, when a shell starts the journey, how long does it take to get to the other end?
About 40 minutes. Any shell that's got any cracks internally, scrap off straight away.
Once they get melted down and put back in, or?
Aye, no good.
So these are the bands, right?
These are the bands that go on the shell, yes.
So what's that made of?
Copper.
Okay, copper ring, and that goes?
That goes on the shell in the first process, goes for the first band press, to get crimped, second band press, to get pushed to the dovetails, then goes into the machine to get machined.
Drones have transformed warfare, not just in Ukraine, but right around the world. And of course, that's had an effect on artillery. Two main impacts. Firstly, for the gunners, an advantage. Surveillance drones can observe their targets, and that helps them correct their fire in real time. Gunner fires, drone watches, sees whether the shell lands on target, short, long, left or right. The gunners correct in real time. It makes them more precise, more quickly, and it avoids the risk of having a soldier, a forward observer, out in that position where they'd be vulnerable. But there's also a disadvantage to the gunners. They can be spotted by drones. The moment they fire, drones might detect them, and then once they've fired, drones can target them, either loitering munitions or FPV drones. So they have to operate a lot more quickly. As soon as they've fired, they have to try and hide or never be spotted in the first place.
So what we have here is we have the shot blast process. First thing that the operator will do is he's clean the nose, then he's going to put the lamp in and he's going to look for any defects within the cavity. He's now going to brush the threads to make sure that there's no contamination in there before he puts the thread gauge in. You can't sell any shell out that's got magnetised in, so we're putting it through the magnetism now.
And that takes away?
That takes the magnetism out of the shell.
Oh wow, how does it do that?
Well, it's a demagnifier.
Okay.
And that's the shot blast process.
The war in Ukraine sparked panic across NATO capitals about stockpiles of 155mm artillery ammunition. We reported here in the UK that Britain's stockpiles would run out in an afternoon of a shooting war with Russia. But of course the problem was far more acute in Ukraine. They needed tens of thousands of shells a month to keep their guns firing. Now, the exact production rates in the UK are strictly classified, but there are plenty of military types who think that production was not enough, is still not enough. To try and get a better handle on this, I went to see Steve Cardew, the Business Development Director of the BAE Munitions business at BAE's London headquarters. So, end of World War II, 43 sites, 16,000 people, and then the beginning of the war in Ukraine, 5 sites, 1,200 people.
Exactly. Yeah.
And where are we now?
So, we heard from very early on in that period, we worked quite extensively with the UK customer to figure out what we needed to do, how much we need to scale our production. And one of the most key elements there was 155, where we scaled production initially 8-fold, but through the course of the programme, we've now moved that to 16-fold. And in terms of number of people, we're now at about 1,800 people. So that's almost a 45% increase in terms of where we were.
A 45% increase in personnel.
And people.
I'm right in thinking the numbers of shells that you make are classified. You can't reveal that?
We can't talk specifically about that.
Steve, what's the most important thing about an artillery shell? What makes these shells better than other shells?
Well, there's 2 things. The sort of the range and the kinetic performance are really important, clearly. That's
how far it goes and what it does at the other end.
Exactly, and that's what the user really sort of expects. But the thing that's probably more subtle, but probably more important, is also the safety performance of the shell. The user really needs to understand that when he fires it, it's going to leave the gun safely and it's going to perform as intended.
Can you talk us through what's happening and what you do?
Yeah, of course. The product comes into here. We load them onto the baskets. The transporter, which is overhead, comes in, picks the baskets up, takes them through the treatment process. The transporter will take it through 7 tanks.
7 tanks?
7 tanks in total, yeah.
And what's each one doing?
The first and second one are got to clean them, clean the shells.
Cleaning it?
Yeah. And then the third and fourth is rinse. So it rinses the guard clean and any dirt and stuff off the shell. Then it goes into tank 5, which is the oxalan, which is the key for the paint. It acts like a primer for the paint to go onto. And then 6 and 7 is a rinse, clean the shell again.
Okay.
And it lands in this bay here. Operators on the bottom, they'll lift them out the baskets onto the table. They'll put the silicon masking band on, which protects the driving band from the paint. They'll put the metal hanger on, which allows them to hang it onto the paint plant, which is the next step of the process.
Fantastic. Can we watch one of these coming out?
Yeah, no bother, yeah. This is the varnishing room, so that's your lance, spray lance there. That goes up inside the cavity of the shell, and that protects the metal from rust, and it makes it smooth so that it can't puncture the explosive bag that goes inside. This is the second last step. It's operation 2 of the bond area.
What's happening here?
What's happening here is when the rubber band that we spoke about before is removed, it can leave a slightly hard edge of paint on the edge of the driving band, which is the copper band. So all that the operator's doing here is removing that hard edge of paint, but you're not allowed to have any paint on the band. This is the nose lifter, obvious reasons. Goes into the nose, clamps inside, and then we use it to lift the shell into the box.
There we have it, a 155mm shell, artillery shell, at the end of its journey through this factory. That is the round that flies from an artillery gun. It's not quite ready to be fired. There are a few other steps that it needs to go through before it is effectively a round that will be handed into the hands of an artillery gunner, a soldier. But in terms of how that bit's made at this factory, this BAE Systems factory here in Washington, that is the end of our journey. And thank you to everyone from BAE. Thank you again for watching Arms Race. If you do have any questions, any comments, if you think we've made any mistakes, let us know in the comments below. Thank you.